here, and then I'm gonna share, come on, what's that? Stop sharing, share the screen. Server specified host name could not be found. What's that? Okay, probably. Oh, okay, it works. Okay, okay, I have to say login. Sorry, guys. So this is. Okay, perfect. Okay, so yeah, so this is this is still section 1.8. So inverse functions, right? And inverse functions. So let me just remind you quickly. And so yeah, homework number 5 is due today, guys, right? And I think there are some there are problems about inverse functions. So yeah, so I'm gonna probably do a couple of examples, but first let me just remind you, you know, definition of inverse function, right? So we said we have a function f. So let f of x be a function. Let f of x be a function. Okay, then the inverse of a function f of x is a function, right? The inverse of a function is a function, right? So then the inverse, then the inverse of f of x is a function, g of x. Let's call such function g of x, such that, so this inverse satisfies the following. So you need f composed with g of x. So be careful, guys. This circle again means it's not multiplication. This is composition, right? It's not product. It's composition. So f composed with g equals to g composed with f of x is equal to x, right? And then I think so. Yeah. So so last week we saw you know, how to find so how do we find the inverse? So the steps. So how do we find? The question was, how do we find the inverse? Right, and so we had probably, I think, basically 3 steps. So step 1, step 2, and we had the 3rd step, which is probably the main and the most important step. Anyway, so step 1, we said we just substitute f of x with f of x by y, and the step number 2, we interchange x and y, and then the last and the main step, we have to solve for y, and we said we cannot always solve for y, or sometimes y is not a function. So, and then the function f has no inverse. But anyway, so we have an exercise, I think, which is similar to the problem 4 in the homework number 5. So this is exercise. Please correct me if I'm mistaken. I mean, so so the exercise was about, so we need to find the inverse of, so I think, if I'm not mistaken, so we have 3 functions. I'm not sure which one I solved actually, but anyway, so so first function f of x, I think it was 3x plus 1. f of x, second function is 4 over x plus 1. And last one was 5 minus x over 1 plus x. Yes?
The first one was 3x plus 4.
3x plus 4. Oh,
Yeah.
okay. Then we solved the second one. Okay.
Yeah, we didn't solve the third one and the first one.
We solved the third or the second?
No, we didn't solve the third one.
Oh, okay. We didn't solve the second. The third one. Okay. So we said 3x plus 4.
Yeah.
Okay. Perfect. Thank you. Thank you, Lenny. Thank you, guys. So yeah. Okay. So we solved the number 2. We solved number 2. Solved last week. So you can check, you can check the notes or the recording last week. Okay, so let's probably do the third function, right? So let's do number 3. Okay, so first step 1, step 2. Step 3, all right. So step 1, we said replace f of x by y. Here's my f of x, right? So f of x is becomes y, so it's y equals 5 minus x over 1 plus x. Step 2, we said we have to interchange, interchange x and y. So y becomes x, y becomes x. So equals to 5 minus, and x becomes y. So it's x 5 minus y over 1, sorry, over 1 plus an x. So x becomes y. So that's 1 plus y, right? Now, now we have this. Now the main step is the last one where we have to solve for y, of course. So solve for y. Now, guys, so we have this equation, 5 minus y over 1 plus y, and we have to solve for y. I think number 2, to solve number 2, we had to flip, both sides of the equation, right? So here, of course, if you try to flip, the problem here is that your y is in the numerator and also in the denominator, right? So even if you flip the fraction on the right side, right, you're gonna still have the y in the bottom, right, in the denominator. Okay, so flipping both sides of the equation won't really solve your problem, right? Because you still have your y in the denominator. So the idea here is that what we can do whenever we have like an equation with the fractions, we can always cross multiply. So let me just write down here the rule for you. So if you have a over b equals to c over d, okay, so if you have 2 equal fractions, then you can actually cross multiply. All right, so then your a times d would be equal to c times b. Right, and that's because when you have 2 equal fractions, it means you have the same ratio, right? If you have the same ratio, then you can always cross multiply. Okay, so here, of course, the right side it's a fraction, but the left side, it doesn't look like a fraction, but you can make it as a fraction by dividing by 1. So you see your x here. If you divide your x over by 1, it's still x, of course. X over 1 is still x, right? But now it's a fraction, right? Now, so now I have fractions both sides, so I can cross multiply. So let's just cross multiply here. Okay, so when you cross multiply, it means that you multiply. So x times 1 plus y equals, then this one here, so 1 times 5 minus y. All right. Okay, so if you distribute, of course, x times 1 would be x times y would be xy, equals to 1 times 5 is 5, and then minus 1 times y is it's y, right? So now, so the goal, guys, is, you want to solve for y. So there's a problem here because we have y on the left side and y on the right side. So what we do in this case, when you have like your variable on the left and on the right side, so what we do is you move your variable the same side, all right, and everything else to the other side. So here I'm solving for y, so I have to move all the y's, all the terms with y, to the same side. Okay, so for example here, this is xy and this is minus y. So what I'm gonna do, I'm gonna move this minus y to the left side. So to move minus y to the left side, I'm gonna add plus y both sides. Okay. So now it's gonna be on the left, so it's gonna be x plus xy plus y equals to 5. So why do we move the y's, all the y's to the same side? Because, so the idea is to factor out, because if you move all the y's on the same side, then y would be a common factor, and so then you can pull out or factor out your y. Okay, so then you can solve for y. Now everything else which does not involve y has to move to the other side. So for example, here there's an x, there's an x here by itself, there's no y here, right, in this term. So this x has to move to the other side. All right, so to move to the right side, I'm gonna subtract x, that's x. Okay, so now it's like, looks like xy plus y equals to 5 minus x. So you see, guys, now I'm happy because now I have all the y's on the left side, and everything else which does not involve y is on the right side. Okay, and the idea is once you have all the y's on the same side, now you can factor out your y. So now I can see here on the left side, here there's a y here, there's a y here, so it's a common factor. So I can factor out y, so there's y times, and then of course, this is x, right? X times y, so then, so it's gonna be x times, y times x, right? So again, you factor out this y here, right? This y here. Okay, so here you're left with the x, and there's a plus, right? There's a plus, and here, if you factor out your y, then you are left with, because it's y times 1, right? So you are left with 1, so it's plus 1. Okay, equals to 5 minus x. So you see, guys, once you factor out your y, then you can get rid of this x plus 1. You just divide here by x plus 1. And of course, when you have an equation, right, whatever you do to one side, you have to do the same to the other side. So if you decide to divide by x plus 1 on the left side, then you have to divide by x plus 1 on the right side. Okay, so then your y, so this, oops, sorry. So then this x plus 1 cancel out, okay, and so your y would be 5 minus x over x plus 1, and so that's the final answer. So the inverse, so final answer. So f inverse, remember, guys, how we denoted the inverse of a function. So it's f power -1. So this notation here means the inverse function. This is the inverse function of f, right? So f inverse is equal to this 5 minus x over x plus 1. So is there any question, guys, how I got this 5 minus x over x plus 1? Okay, so whenever you have an equation of the fractions, I mean, usually what we do is either you flip, you can always flip both sides, or you can cross multiply. Okay, that's like your two. You have like two options: flip or cross multiply. Whenever you have an equation of the fractions, all right. And here, of course, if you flip, like again, if you flip this side here, I mean, it doesn't really help because you're gonna still have an y in the denominator. So then the second option would be just to cross multiply. Any question, guys, about this number third function here? Okay, there's no function. Sorry, there is no questions. Then so we solved number 2, unless there is any specific question about number 2. I mean, I can solve it again if you want, but I mean, if we solved it last week, then it's not. I guess it's not really needed, unless you want me to do it. For number 1, it's just of course, number 1 would be much more easier than number 2 and 3. Number 1, so let me just number 1 is kind of it's not really hard. So for number 1, you have f of x equals to 3x plus 4. So let me just write down here the steps for you. So step 1, step 2, and then of course the last step. And so step 1, you replace f of x by y. Step 2, you interchange x and y becomes x, and x becomes y. And then you have to solve for y. So here you only have one y, I mean 3y on the right side. So you can just subtract 4 from both sides. So that will be x minus 4 equals to 3y. All right, and we're almost done. So now you can just divide both sides by 3. There's an over 3, and so your x minus 4 over 3 equals to y. Okay, so then f inverse, so by an answer, of course, f inverse. So this is your answer. So f inverse of x is x minus 4 over 3, right? Any question, guys? Okay, so no questions then. As I said, okay, let's just finish this section. Last remark. So as I said, we cannot we cannot always solve for y, or sometimes y, you end up with y which is not a function of x. So let me just remind you here. Remark. So we cannot always solve for y. Always solve for y. Okay, or sometimes y is not a function. Y is not a function, right? So if you cannot solve for y, or if your y is not a function, then so then f of x has no inverse, right? So sometimes your function, I mean, not all the functions have an inverse, right? So then f of x has no inverse. So for example, I think I made before this example, but anyway, let's do it again. So example, so if you say, for example, f of x is x squared, right? And if you follow the steps, you want to find the inverse, f of x replaced by y, then you have to change x and y. So x is y squared, and then you want to solve for y. So of course you apply square root both sides. So here's a square root, here's a square root, but then because the power is even, right? So if the power is even, then you're gonna need a plus or minus here, right? So then this is this square root here cancel out with the square, of course. Then your y would be, you know, plus or minus square root of x, right? And of course, this is y here is not a function of x because remember, guys, in order to be a function for each input x, there is exactly one output, right? And here, of course, if your input x is 1, then you're gonna have two possible outputs, plus or negative 1, right? And so then your y, so y here, sorry. So then your y is not a function of x, okay? Because because there are two possible outputs. Two possible outputs for okay, right? The plus or minus, right? Because of the plus or minus, because of this plus or minus, right? So it's not a function. And so this function f, the x squared has no inverse. So this x squared. So f of x oops, sorry. So f of x equals 2x squared has no inverse. All right. Anyway, so now, so this is so that's how we find the inverse using equations, right? Now, when we have graphs, so now the question is, how do we determine whether function f has an inverse using graphs? So here now the question, so next question is, so how do we determine whether f of x has an inverse using graphs? Determine whether f of x has an inverse if using graphs. Okay. Well, so the idea is the following, guys. I mean, you know, let's say you have a function f, right? So let's say you have this, you know, you have this function f, so it's f of x. So let's say here I have an input, and this is your outputs, okay? So if you say, let's say, so this is, of course, here you have your inputs x, and here you have the outputs y. All right, so, you know, let's say this input x would go here. The next point, let's say, corresponds to this one here, the third one here. All right, and then the third point, let's say this one here, probably I'm going to use just a, oh, okay, I'm going to use green again. So so this one here goes to the, sorry, so the third point goes to the second one, right? So this one goes here, right? Now the question is, does this function f have an inverse? Okay, So now the question is, can we go from the set of outputs to the set of inputs? So if you, I mean, you have this, first, you have this first, the first arrow here, this one here, right? It goes from, it goes from this point to this one, right? So now I'm gonna reverse the arrow. So now I'm gonna reverse the arrow, and so I'm gonna go from this point to this one here, right? Next, I'm gonna have, I'm gonna reverse the next arrow, this one here, right? And then the next one, this one here, is gonna go from this point to this one, right? So I'm gonna have like, so if you reverse the arrows, then you're gonna have a mapping, you're gonna have, let me just, so I have 3 points here. So this is supposed to be my outputs Y, and this is my inputs X. Okay, I have 4 points here. And so I have my red arrows now. So this point is gonna go to this one. The second point, this one here, is gonna go to the third one. So second one here, go to the third. The last point here, when I reverse the arrow, is gonna go to the second one here. So the third one in the outputs Y is gonna go to the second, right? It's gonna go to this one. All right. So the question now, is this a function? Well, it's a function, right? Because for each input you have exactly one output, right? So this is a function. So if you reverse the arrows, right, you're gonna have a function. So this is a function, and it's gonna be actually the inverse function. So this is when you reverse the arrows, you get your inverse function, right? Because you remember, guys, how we find the inverse function, you have to interchange X and Y, right? X becomes Y and Y becomes X, right? So if you have to reverse, in some sense, you have to reverse the arrows. So now we're gonna go like from Y to X, right? So this is the inverse function. The inverse function. Okay. But the thing is, if you reverse the arrows, okay, then sometimes, so this is, let's say this is example 1. If you reverse the arrows, sometimes you don't get a function, right? It's because, so this is example 1. Okay, now let's have another example. Example 2, very simple example. Let's say example 2. So I'm gonna have, let's say, just 2 points here and 1 point here. All right. So this is my inputs X, and this is my outputs Y. All right. And let's say you have this function F. So this point here goes this one here, and this one here goes here, right? This is my function F. It's a function, right? Because for each input, for each point from the first set, there's exactly one output. There's exactly 1 point in the second set. So it's a function here, right? Now, if you reverse the arrows, when I say reverse the arrows, it means like, in some sense, interchange X and Y. So if you reverse the arrows, so here I'm gonna go from this point to this one. That's my first arrow, and I'm gonna reverse the second one here, right? So now, let me, so if you start with the outputs Y, my outputs Y here, right? I have 1 point, and the inputs X, I have 2 points, right? This is my inputs X. And now, if you draw the arrows, so here I have actually 2 arrows, right? 2 red arrows, right? From this point to this one here. Now the question, is this a function? Is this mapping here, is this a function? No, right? Because, yeah, absolutely, guys, because for this, you know, for this input, sorry. So for this input, right, I have actually more than one output, right? I have two outputs, right? So this is not a function. This is not a function, right? Because for this input here, I have actually two outputs, two possible outputs. So it's not a function. So this function f of x, this function f of x has no inverse. F of x has no inverse. Okay. So what went wrong with this example? Why this function f has no inverse? Well, because I have these two inputs, right? I have these two inputs, right? And the two inputs, they have the same output, right? So when you reverse the arrows, then you know you're gonna have one input which corresponds to two outputs, right? So that's actually a general fact. So whenever, if you have two inputs having the same output, right, then your f of x has no inverse. So this is like, so it's a general fact. So this is our statement. So in general, so if two inputs x, if two inputs x, sorry, there are messages in the chat. I didn't see them. Okay, thank you guys. Okay, yeah. So if two inputs x have the same output, okay, the same output y, then f of x has no inverse. Then f of x has no inverse. Okay, so that's like a general fact. And I mean, you can check it, for example, you know, we had this example with the x squared, right? We said, remember guys here, we said the function x squared has no inverse, right? So if you graph x squared, okay, let's graph x squared. Here. So graph of x squared. So let's say this is 1, 2, -1, -2. This is 1, 2, 3, and 4. Okay, so 1 squared is 1, -1 squared is 1, 0 squared is 0, 2 squared is 4, and -2 squared is 4, +4, right? So this is a graph of x squared, right? So this x squared, we said, has no inverse, right? Remember we said has no inverse because when you solve for y, you're gonna end up with plus or minus, and so it's not a function, right? So, and here you can see, if you take, for example, -2 and +2, so you see here, if you take this +2 and this -2, all right, then +2 and -2, they have the same output, right, which is 4. Okay, so these two inputs, -2 and +2, they have the same output, right? Then you see here, we said if two inputs x have the same output, then f of x has no inverse. And like here for this x squared, so a -2 and +2, they have the same output, right? Y, which is 4. Okay, so if two inputs x have the same output y, then f of x has no inverse. Then my f of x here, then my f of x has no inverse. No inverse. Okay, so that's the general idea. So whenever you have a function and like you have like two inputs, they have the same output, then your function has no inverse, right? And how can we check if we do have two inputs with the same output? If you want to check it on a graph, so what you can do is we can use horizontal lines. So because like here, if I use this horizontal line, right? So this horizontal line means that my output y is 4, right? The horizontal line here means that my output y is equal to 4, right? So if my horizontal line with output 4 intersect the graph at 2 points, at this point and this point, it means that my output 4 has actually two possible inputs, okay? So if your horizontal line intersect the graph at more than 1 point, so if it intersect the graph at 2 points, like here, all right, then it means that your function f has no inverse because your output, which is represented by this vertical line, sorry, by this horizontal line, has actually two possible inputs, right? So that's actually what we call the horizontal line test. So the horizontal line test says the following. So if you have a horizontal line which intersect the graph at more than 1 point, then the function f has no inverse. So yeah, so that's what we call the horizontal. So that's the horizontal line test. Okay. So what does it say in the horizontal line test? So if a horizontal line intersects the graph of f of x at more than 1 point, at more than 1 point, then f of x has no, then f of x has no inverse. Okay. So if you have just one, I mean, a single horizontal line which intersects the graph at more than 1 point, then your function has no inverse. Okay, so let me do a couple of examples here. There's a couple of graphs. Example. For instance, let's say I have this. Let's say I have this graph here. Okay, this is my f of x. So, like in this example, of course, if you take, let's say, if you take this horizontal line here, okay, it's going to intersect the graph at 2 points. So then you are done. Your f of x has no inverse. Okay, so then f of x has no inverse. Okay, another example, let's take x cubed, a graph of x cubed. So this is example 1. So example number 2. So I'm going to graph x cubed. X cubed. So the graph of x cubed actually looks like the following. It looks like something like this. Okay, so this is x cubed. Anyway, so well, for the graph of x cubed, you can see if you take any horizontal line, I mean, like this line here, or this one, etc., right? All the horizontal lines, they're going to intersect the graph at exactly 1 point, right? So then your function f has an inverse. So this x cube actually has an inverse. So then, so this case, sorry. So then f of x has an inverse. All right. So yeah, so we can use this horizontal line to check whether f has an inverse or not. And again, the idea is, you know, it's because for each output, okay. So if you have an output with more than one input, okay, then your function f has no inverse. Again, like this example with the x square. So you can see, like, if your output y is 4, right? If your output y is 4, then there are actually two possible inputs, and that means that actually you cannot really, you cannot really reverse. I mean, if you reverse your arrows here, then actually it won't be a function, right? Anyway, so is there any question, guys, about this horizontal line test? I mean, it's very easy, convenient test, I guess. Okay, perfect.
I have a question.
Yeah, sure.
So it's about the function. So whenever we see a function with a like a square root, like a power of 2, like x squared, x to raise to the power of 2 is not a inverse.
Yeah, yeah, absolutely. If you have actually, whenever I have an even power, then the function has no. I mean, the highest power of x. Of course, you have to check the highest power of x. If the highest power of x is even, then the function f has no inverse. But if the highest power of x is odd, like here x cubed, right? It's odd, then yes, f has an inverse. All right. So yeah. So answer your question again. Actually, all you have to do is to check the highest power of x. If it's even, then f has no inverse. But if it's odd, then yes, it's going to have an inverse. Is there any other question, guys? But anyway, I mean, yes. And you can, if you have the graph, of course, you can just use this. You can use this. This horizontal line test. Any other question, guys? Okay, so then let's do an exercise. I'm going to just give you 2 or 3 graphs, and then you have to determine whether the function has an inverse or not using this horizontal line test. Exercise. So we have to determine whether f of x has an inverse. Okay. So this is my first. Okay, so number 2 and number 3. So here's number 3. Right. So number 1, number 2, number 3. So for number 1, so let's say you have this form of function. Right. So this is your f of x. Number 2. Now let's say your function f is going to be okay, so this is f of x, and last function. So f of x. So let's say okay, so this is your f of x. Okay. So yeah, so yeah, so you have to determine, guys, whether the function f has an inverse or not. So you have a couple of minutes. All you have to do is to use this horizontal line test, right? Yes, yeah, Kwame, absolutely. Number one has no inverse, yes. Yeah, yeah, absolutely. Glenn, number three, yeah, has no inverse. Yeah, absolutely. And what about number two?
I had said that number 2 is an inverse.
Yeah, 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 absolutely. Yeah. So yeah, yeah, thank you, guys. So for number one, yeah, Lenin, absolutely, yes. So for number one, of course, if you take, I mean, this, let's say, oops, if you take this horizontal line here, it would intersect the graph at just one point, which is good. But then if you take a horizontal line here, just be careful. If you take a horizontal line here, like in the middle, you know, then you can intersect the graph at more than one point, like 3 points, right? So that then because of that, then this function f has no inverse. So here it has no inverse. For number two, I mean, any horizontal line would just intersect the graph at exactly 1 point, right? So this 1 point, 1 point, 1 point, 1 point. So yes, then this function f has an inverse, has an inverse. And the last one, I mean, if you take, if you take any horizontal line, actually, like here, we would intersect the graph at like 4 points. All right, that's more than 1 point. So then, of course, this function f, the third one, has no inverse. All right. Is there any question, guys?
Yeah.
So that's, yes, please, yeah, go ahead.
So if the graph starts with an inverse and ends without an inverse, the whole graph is not inverse, right?
Sorry, I didn't understand. You're saying if just one, like one
Yeah.
horizontal line?
If the graph starts with an inverse, but ends, if the graph starts with an inverse, like the horizontal line passes through and it doesn't end with an inverse, does the whole graph become a graph without an inverse?
You mean, does the graph, is the graph would be the inverse of itself?
No, like question
I don't.
one, like question one.
Oh yeah.
Yeah,
That's
it
has
starts
no
with
inverse.
yes, but ends without an inverse. So the whole graph becomes an inverse, becomes a graph without an inverse, right?
Yeah, yeah, of course. Yeah, of course. Yeah, yeah, of course. The whole graph has no inverse. Yes. Yeah, I mean, even if you have just like here, you have this line intersect the graph at 1 point, but it doesn't really matter because you have another one here with 3 points, right? So then the whole graph has no inverse. Yeah. So I mean, if you have only one horizontal line which intersect the graph at more than 1 point, then you are done. Okay. It doesn't really matter if you have horizontal line intersecting the graph at just exactly 1 point. It doesn't matter. If you have one which intersect the graph at more than 1 point, then you are done. Then your function f has no inverse. Does this answer your question? Well, I hope it answers your question.
Yeah.
Okay, perfect. Okay, perfect then. Is there any other question, guys? Okay, perfect. Then, yeah. So then we are done with this section 1.8. You know, so I think we did. We covered everything in this section 1.8. I mean, you know how to check whether two functions are inverse of each other. You know how to find the inverse of a function using equations. And if you have a graph, then you know how to check whether the graph, the graph of the function has an inverse. Anyway, so yeah, so we are done with this chapter 1. That's the last section in chapter 1. So the whole chapter 1, guys, is gonna be in the test. And now I guess we can move to the next. I can probably move to the next page, and we can start chapter 2. And we're gonna start with section 2.2 in the chapter 2, and it's about quadratic functions. So the goal of this section, I guess you know what's a quadratic function, but anyway, I'm gonna remind you, of course, the definition of quadratic functions. But I mean, the goal of this section is just to graph, to know how to graph quadratic functions. It's a very short section, actually. So this section is also included in the test because it's very short. So it's also included in the test. So plus chapter 1. Okay. Okay, so let me just first remind you what's a quadratic function. Well, whenever I have a function of the form like ax squared plus bx plus c, then that will be a quadratic function, right? So functions of the form f of x equals to ax squared plus bx plus c, all right? With a non-zero, this is really important. If your a is 0, then it's not a quadratic function, right? So with a 0 are called are quadratic functions. All right, and actually, so for example, so that's the definition. Now examples. Again, so f of x, for example, equal to negative 3x squared plus 2x minus 1. Of course, I mean, this is of the form ax squared plus bx plus c. I mean, your a would be, you know, negative 3, your b would be 2, and your c would be negative 1, right? This is your a, this is your b, and here's your c, right? Just the numbers, right? So that's this function f is quadratic, right? This is a quadratic function. It is quadratic. Okay. Of course, now if you have a power, let's say a cube, or let's say you have x cubed minus 2x squared plus x plus 4. Okay, because of the cube. You know, this is a cube. So then, of course, then this function f is not quadratic, right? It's not ax squared plus bx plus c, because you have this x, they have this extra term, right? The x cubed. So then f of x is not, this is not quadratic. Right? Now, you can also have like a quadratic functions with b or c equal to 0. So for example, if you have you know, f of x, let's say it's minus 2x squared plus 1, then yeah, it's okay. Then this is your a is negative 2, which is good. Your b, well, there's no x, right? I mean, here there's no x, right? So then if you have no x, then your b is 0, right? And then there's this constant by itself, that will be c, so c is +1. All right, so if there's no x, then your b is 0. But again, that's fine. If there's no x, it's still a quadratic function. So this f of x is quadratic, right?
Professor, I got a question.
Yes, yes, sure.
So number 2 is not a function because it has 4 terms.
No, I'm not saying it's not a function. I'm saying it's not a
And not a
quadratic function.
quadratic function.
Yeah, because of the cube.
Oh, okay.
So if you have, yeah, so what I'm saying, if you have a power, if the highest power of x is not 2, then it's not quadratic, right? If you have power 3, power 4, etc., then it's not quadratic function, right? Now, if your a is 0, so for example, if your let's say your f of x is if your f of x is let's say it's 5x plus 1, right? So what would be a in this case? Remember, a that's
0.
the coefficient 0, right? That's the coefficient of x squared. Your a is 0, and that's a problem. If your a is 0, then so here your a is 0 because there's no x squared. Your a is 0, then this is not a quadratic function actually. So f of x is not it's not quadratic. Actually, this kind of functions are called linear function, right? But anyway, yeah. So this is not a quadratic function, all right? Because your a is 0. There's no x squared. If there's no x squared, okay, now then it's not a quadratic function, right? Of course, you can have powers, like if you have an f of x, so this is my last example, let's say. So if you have powers, let's say f of x is negative 2x to the power 15, minus x to the power 10, and then you have an x squared plus x plus 1 or minus 1, all right? So it doesn't matter if you have a square here, but because you have powers larger than 2, okay? So if you have power larger than 2, then your function is not quadratic, right? So we have powers larger than 2. All right, so we have this, we have this 15 and the power 10 larger than 2. Then of course then f of x is not. It's not quadratic function. It's not quadratic. Okay. Yeah. So yeah. Is there any question, guys, about this definition of quadratic function? It's ax squared plus bx plus c, and very important, your a must be non-zero. If your a is 0, then it's not a quadratic function, right? Okay, so there's no question, guys. Now we are interested in the graph of quadratic functions. Okay, so that's the goal. That's what we're gonna do today, and that's the whole section, the section 2.2. So the goal is to graph quadratic functions. So actually, the graphs of quadratic functions are called parabolas. Okay, so graphs of quadratic functions they are called parabolas. All right. Okay, so so what I'm gonna do, I'm gonna graph an example of quadratic function, and we're gonna take a very close a close look to this to the graph of the function to the quadratic function. So let's have an example. Here's an example. Let's take very simple quadratic function, the simplest one, I guess, which is x squared. F of x equals to x squared, right? So your a would be, so this is 1 times x squared. So your a is 1. There's no x, so it's like 0 times x. And there's no constant c, so it's like plus 0, right? So your a is 1, your b is 0, and your c is 0. But still, even if your b and c are 0, it's still a quadratic function. So this f of x, of course, x squared is a quadratic function. Because your a is not 0, right? Is quadratic function. Okay, yeah, so now next, so as I said, we are interested in the graph of this quadratic function, the x squared. So I'm gonna just graph very quickly x squared. So it's gonna look like, you know, it's a parabola, of course. So 0 squared is 0, 1 squared is 1, 2 squared is 4, same here. For -1 and -2. So here's my parabola. Okay, so this is my f of x equal to x squared. Right. Anyway, so what are the well? Let's see what's the properties of this parabola. So first, there is you can remark there's a very special point, which is this one here. So this point, which is like the lowest point in the graph, right? This point is called the vertex of the parabola. So this is the vertex of the parabola. All right. It's the vertex of the parabola. And so it's, as I said, it's the lowest point in the graph. So that would be like, the vertex would be like a minimum here, right? That's like a global, it's the lowest point in the graph. So that's the global, it's a global minimum, right? It's a global minimum. Right? Now, you can see that actually this parabola is kind of, it's actually symmetric about the y-axis. So you see here, this is my y-axis, the vertical axis, this one, right? And you see there's like a reflection about this y-axis. So what I mean by reflection about the y-axis, so you see you can, like this point here, this one here goes, you know, to this point. This one, its image by the reflection would be this point. You know, there's sort of reflection about the y-axis. You know, so this y-axis, or the yellow axis, is actually an axis of symmetry. So this is an axis of symmetry. This is an axis of symmetry. So your parabola is symmetric about this y-axis, right? And what's very special about this axis of symmetry? It passes through the vertex, right? It passes through the vertex. So once you know, passes through the vertex. You know, once you know your vertex, then you know that your axis of symmetry of the parabola actually, it's going to be a vertical line. This axis of symmetry is a vertical line, right? It's a vertical line, and it's going to pass through the vertex, right? Another thing about this parabola is that it opens up, right? So because, for example, so I'm gonna take another example, example 2, and in example 2, I'm gonna I'm gonna graph minus x squared. Example 2. Let's say my f of x is minus x squared. All right. Of course, this is a, I mean, it's a quadratic because your a is, you know, it's not 0, it's -1. Your b is 0, your c is 0, right? But so anyway, your a is not 0, so it's is a quadratic function. It's quadratic. But anyway, if you graph, you want to graph minus x squared, so then you know, well, probably I don't need this thing here. Sorry. So I was saying you want to graph minus x squared, you know, so it says 1, 2, -1, -2, right? 0 squared is 0. Now, +1, I mean, x is 1, then -1 squared is going to be -1, right? X is 2, 2 squared is 4, and then you have minus, so that will be -4. X is -1, -1 squared is +1, this is in the negative, so it's -1, and same for -2. So for -2, -2 squared, it's a +4, but then there is a negative, so that would be a -4. So anyway, so what I'm saying, the graph of -x squared would be this one here. Yes, absolutely, Glenn. Yeah, very, 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 very good observation. Yeah, so it's going to be a reflection above the x-axis of the x squared. Absolutely, yes. Yeah, that's minus f of x, so it's a reflection above the x-axis. Absolutely. But now you see, guys, the difference between the, you know, this positive x squared and the negative x squared is that the positive x squared, the parabola opens up. The negative x squared, the parabola opens down, right? So this parabola here, so this one here, the parabola here, opens down. Right? And actually it opens down because your a is negative. Okay, so whenever a is negative, then your parabola opens down. So because actually a is negative. In our previous example with the positive x squared, the positive x squared, a is positive, right? Here, your a is a +1. See here, a is positive. So when it's positive, when a is positive, then the parabola opens up. The parabola opens up. All right. Of course, here when it opens down, then the vertex would be like the highest point in the graph. So though it would be a global maximum. So this is, of course, this would be your vertex. And when it opens down, your vertex would be your global maximum, the highest point in the graph, right? Yeah, so you see the difference when you have a positive, when you have a negative. A positive, your vertex would be the global minimum, and I mean the lowest point in the graph, and your parabola is going to open up. When a is negative, your vertex would be a global maximum, that's like the highest point in the graph, and your parabola opens down, right? Yeah, and of course, you still have an axis of symmetry. I mean, you see here, again, the same, the y-axis is going to be an axis of symmetry because you can see here, you know, this point is going to, its reflection about the y-axis would be this one. This point here is going to go like here. This one here, it goes here, etc. Right? So you still have this axis of symmetry, this one here. Of course, that will be your axis of symmetry. So this is like general fact. I mean, whenever you have a parabola and whenever you want to graph a quadratic function, then you're going to have a vertex. Your vertex is going to be global maximum or global minimum, depending on your A, if A is positive or negative, right? You're going to have this axis of symmetry, right? And yeah, and then, yeah, that's actually all you need to graph your, probably with also with the x-intercept, you can also graph the x-intercept, plot your x-intercept, your y-intercept, and then you can graph your function f. Anyway, so let me now show you so let me give you now the general steps to graph a quadratic function, right? So general steps to graph a quadratic function. Okay, and so what I'm gonna do, I'm gonna show you the steps and with an example, right? So I'm gonna do an example with the steps. Yes. Is there any question, guys? Nope. Okay. Okay. So for step one, so I'm gonna here divide. So here's my steps, and here my example. All right. So let's say my example is let's take a very simple example. So let's say it's x squared. So f of x. So let's say it's x squared, right? X squared minus, let's say minus 3x, right? Plus 2, right? So this is, of course, a quadratic function. You know, your a is, it's 1 x squared, so your a is 1. A is positive. So you know your a is positive, then you know that your parabola is going to open up. Your b is negative 3, of course, it's minus 3, and your constant is 2. So again, because your a is positive, then the parabola is going to open up, right? Because it's positive 1, right? Anyway, so first step to graph this quadratic function is to find the vertex. And we do have a formula for the vertex, right? So the formula is the following. So your vertex is going to be the coordinates of the vertex. So the vertex is going to be equal to, so here's the formula. So the x coordinate would be minus b over 2a, and the y coordinate is going to be f of minus b over 2a. All right. So like here in our example, the vertex, right? So the vertex is going to be, so the x coordinate, so this is, again, this is the point coordinates, point notation. So this is the x, your x coordinate, and this is, of course, your y coordinate. All right. So in our example, the vertex is going to be, so minus, I have to compute minus b over 2a. So it's minus, b is, where's b? B is negative 3, right? So it's negative 3 over 2 times a, 2 times 1. So it's positive 3 over 2. Okay, so it's 3 halves, right? That's the x coordinate. Then the y coordinate, right? So the y coordinate would be f of So now we have to compute f of negative b over 2a, which is f of 3/2, right? 3 over 2. Okay, so what's f of 3 over 2? F of 3 over 2. So, you know, the function f is x squared. So it's going to be 3 over 2 squared minus 3 times x, so minus 3 over 2 plus 2. Right? So let's compute this thing here. I mean, just be careful with the fraction, guys. You know, this is f of 3 over 2. So 3 over 2 squared, it's 3 over 2 times 3 over 2. Right? This is 3 over 2 times 3 over 2. This is like 3 over 1, right? So it's you multiply straight across. So minus 3 times 3, that's 9. So minus 9 over 1 times 2 is 2 plus 2. All right, so that's 3 times 3, it's 9 over 2 times 2 is 4. So 9/4, 9 over 4 minus 9/2.
Wait, Professor, you're going a little bit too fast.
I'm just, yeah, I'm.
So wait, where did
Yes.
you got 3 over 2 with the 2 outside minus
Yeah,
3 over 1 times 3 over 2.
Yes.
Where did you get 3 over 1?
Okay, that's because I didn't have the 3 over 1. Actually, I had 3 here, right? Because you see, this is your function f, it's x squared. Sorry. Function f is x squared minus 3x plus 2, right?
Mm-hmm.
So what I'm gonna do, I'm gonna plug 3/2 in the function f. So it's 3 over 2 squared minus 3 times this 3 over 2. Your x is 3 over 2 here, right?
So you're just replacing everything with 3 over 2.
Yeah.
Okay.
Yeah. And yeah, absolutely. And then yeah, I was saying, I mean, this 3 times 3/2, you know, because you multiply a whole number by a fraction. So I'm just dividing the 3 by 1, so I can make it like a fraction, and then you can like multiply like straight across here. Like 3 times 3 would be 9, and 1 times 2 would be 2.
All right.
You see what I'm saying? And then there's this 3/2 squared. 3/2 squared, that would be, you know, 3 times 3, and then 2 times 2, that would be 9 over 4. And now I end up with, sorry. So I end up with this 9 over 4 minus 9 over 2 plus 2, right? So I have a subtraction of fractions, 9 over 4 minus 9 over 2. So I need the common denominator, and the common denominator would be 4. So I have to multiply here by 2 and here by 2, right? And then here, same for the plus 2, because, okay, let's do first the, okay, let's do this first. So we're gonna have 9 over 4 minus 18 over 4 plus 2. So that would be 9 minus 18 over 4. And then there's this plus 2. 9 minus 18, of course, is negative 9. So it's going to be negative 9 over 4 plus 2. All right. Now, we have a fraction plus a whole number. Again, whenever you have fraction and a whole number, it's better just to make the whole number look like a fraction. So I'm going to divide by 1 here, right? And then, of course, you need the common denominator. So the common denominator would be 4. So I have to multiply here by 4 and here by 4. So this is, again, this is, oops. So this is supposed to be f of 3/2. So f of 3/2. So it's negative 9 over 4 plus 8 over 4. Negative 8 and negative 9 plus 8, that would be negative 1. And common denominator is 4. So it's negative 1 over 4. Okay. So, so what I'm saying, guys, is that my vertex, so the x coordinate of the vertex is this 3/2, the minus b over 2a. That's my x coordinate of the vertex. That's the 3/2, and the y coordinate would be this negative 1/4. So this thing here, negative 1/4, that's the y coordinate of the vertex. So find an answer here for the vertex. The answer. So the vertex. So this is a point notation. So first, I need my x coordinate. My x coordinate is this negative, sorry, it's positive 3/2, 3 over 2. That's minus b over 2a, 3 over 2. So it's the 3 over 2. And then the y coordinate is this negative 1/4. This is negative 1/4. Right. Again, guys, this is, I mean, if you are lost, so what I am saying is this, the formula for this x coordinate is minus b over 2a. And for this y coordinate, you just compute f of this negative b over 2a. So like here in this example, negative b over 2a would be 3/2, and f of 3/2 is actually negative 1/4. Right? That's my vertex. That's the coordinates of my vertex. Is there any question, guys, about this formula for the vertex? All right. Okay, I got my vertex, which is good. Now, second step. So this is my first step, graphing my quadratic function. So we said, remember, we said step one, we need to find the vertex, and we have this formula for the vertex. Okay. Now, next step, we have to find graph. If you want to graph a quadratic function, next step would be to find the x-intercept and the y-intercept. So step two. So we have to find the x-intercept. Remember, guys, the x-intercepts are the intersection of the graph with the x-axis. Intersection of the graph with the x-axis. And how do we find the x-intercepts? Well, all you have to do is to solve f of x equal to 0. Okay, that's how we find the intersection of the graph with the x-axis. Solve f of x equal to 0. My example, f of x in my example is, where is it? It's the x squared minus 3x plus 2. So x squared minus 3x plus 2. X squared minus 3x plus 2 equals to 0. All right. And how do we solve this equation? Well, we have two options. Either you factor, or you can just use the quadratic formula, right? Let me just remind you quadratic formula. So let's probably just use the quadratic formula. It's minus b, plus or minus, b squared minus 4ac over 2a. So like in this example, that would be minus negative 3 plus or minus square root b squared negative 3 squared, that's 9, minus 4 times a, 1, and then c is 2, right, over 2a, it's 2 times 1, right? So your x is a minus negative 3, that's positive 3, plus or minus square root of 9 minus 4 times 2, that's 8. 9 minus 8 is 1. Square root of 1, it's 1. So it's plus or minus 1 over 2. Okay. So actually, there are two solutions, or two x-intercepts. So x is plus 3 plus 1 over 2. So that would be positive 2. 4 over 2, that's positive 2. Or x is 3 minus 1 over 2. That would be 2 over 2. That would be positive 1. Okay, so what I am saying is here we got two solutions, positive 2 and positive 1. All right, so the answer here for the x-intercepts, remember guys, x-intercept should be, the notation should be the points notation. So answer x-intercepts are, so first solution is 2. So it's gonna be 2, 0. The y is always 0 in the x-intercept. And second solution is 1, 0. Again, here, your y is always 0. Always, y always 0. Right? Y always 0 in the x-intercept. Okay? So I got 2 x-intercepts, right? 2 and 2, 0 and 1, 0. So that's the second step. Find the x-intercepts. Third step would be to find the y-intercept, and then we are almost done. So step 3 would be to find the y-intercept. So let me remind you guys, the y-intercept, that would be the intersection of the graph with the y-axis. So find the y-intercept. So that's the intersection of the graph with the y-axis. Right, and how do we find the y-intercept? Well, you just evaluate f of 0. Evaluate f of 0. That's all you have to do, right? So you just plug 0 into the function f. So f of 0 would be like, you know, x squared, so it's 0 squared minus 3x minus 3 times 0, and then plus 2, if I'm not mistaken. Yes, plus 2. And then plus 2. All right, so f of 0 is actually positive 2. Okay, so then the answer, y-intercept, the y-intercept is, so again, use the point notation, so it's 0, 2. The x is always 0 in the y-intercept. This is, x is always 0. Always 0. Okay, and of course the answer here is 2, so I got 2 here. So the y-intercept is 0, 2. So I got my vertex, my x-intercept, my y-intercept, and then I can plot all these points in the graph, right? Last step is just to mention the axis of symmetry. So remember, guys, we had an axis of symmetry. So in the step 4, we need to find the axis of symmetry, but axis of symmetry would be a vertical line which passes through the vertex, right? So the equation of the axis of symmetry is just the same as for the vertex. It's x equal to minus b over 2a. So the axis of symmetry, so find, in the last step, find the axis of symmetry. Axis of symmetry of the parabola, right? So the formula is just the following. It's the same as the vertex, so x equals to minus b over 2a. Okay, and of course this axis of symmetry is always a vertical line. This is a vertical line. Okay, it's always a vertical line. It's always a vertical line. A vertical line. It passes through the vertex. Vertical line. So, like in our example, x, it's minus b. So minus b is negative 3. So it's negative 3 over 2 times a, 2 times 1. So it's positive 3 over 2. It's the same as the vertex, right? So that's the equation of my axis of symmetry. So this is here, that will be the answer here. Here's the answer. So my axis of symmetry is x equal to 3 over 2. So yeah, so those are the steps. Now I can graph my parabola or my function f. Okay, so now we can graph graph of f of x. So we said f of x is x squared minus 3x plus 2, right? So okay. So let's say this is, here's 1, 2, 3, 4, etc. -1, there's +1, -1, +1, etc. All right. And so first, I'm gonna plot the vertex. Okay, so first, I'm gonna plot the vertex. So vertex, we said it's, you know, it's 3 halves and -1 over, where is the vertex? Let's see. Yeah, here, right here. So it's 3 over 2, -1 over 4, right? So 3 halves, -1/4, halves, -1/4, a vertex. So it's 3 halves, -1/4. My x is 3 halves. So here's 3 halves is 1.5, right? So here's my 1.5. And then my y is -1/4. So it's negative, so I'm gonna go down here, and that will be, let's say, that's the -1/4 right here, -1/4, let's say, okay? So this point here, this would be my vertex, right? So because this is supposed to be 3 halves, and this is supposed to be -1/4, right? So that will be my vertex. So I plot my vertex. Now I'm gonna plot the x-intercepts and the y-intercept. Plot the x-intercepts and y-intercepts. Right. So x-intercepts we had. Where's x-intercepts? X-intercepts. So it's 2, 0, and 1, 0. 2, 0, and 1, 0. So 2, 0, 1, 0, and then y-intercept is 0, 2. Okay, so let's plot these points. So let's start with 2, 0. Well, here's 2, 0. And then 1, 0. So here's 1, 0. And then 0, 2. So here's 0, 2. Right? So again, guys, this is like 1, you know, this is 1, 2, 3, etc. Right? So I got my x, y-intercepts. Now I'm gonna draw the x. Last thing to do is to draw the axis of symmetry. Axis of symmetry. Axis of symmetry. And we said axis of symmetry is the same. It passes through the vertex, right? Axis of symmetry is x is equal to 3 halves. It's a vertical line, and it passes through my vertex. Again, here's my vertex. This is my vertex, guys. Right? So my axis of symmetry, it passes through the vertex. Is x is equal to 3 halves. So here's my axis of symmetry. Right? This is my axis of symmetry. All right. Well, okay, so now I have everything I need to graph my function f. Remember, guys, this is very important remark. My f of x, you know, my f of x was x squared minus 3x plus 2, right? So my A is positive 1, right? My A, it's positive 1, right? So if A is positive, then the parabola opens up, right? So if it opens up, it means that my vertex is a global minimum, right? My vertex is going to be a global minimum because it opens up, right? So my vertex would be the lowest point in the graph. Okay, so this is supposed to be the lowest point of the graph. Now I'm going to just, connect my points, my x-intercept and the y-intercept. Remember, this is supposed to be, the yellow line is supposed to be axis of symmetry. So it's like, it's supposed to be symmetric about the yellow line. So would go like this here, right? Like, again, axis of symmetry means like if you have this point, then its reflection about the axis of symmetry would be this point. If you have this point, then its reflection about the axis of symmetry would be this point, etc. But anyway, all you have to do, guys, is to join your vertex to your x-intercept, to your y-intercept, and then you get your graph, right? So, and this, again, it's supposed to be a parabola. It's supposed to open up here because it's positive. A is positive. So this is my f of x. Okay, so that's the graph of f of x. Any question, guys? So you see the steps. This is again, the steps is vertex, x, y-intercepts. You get your x, y-intercepts. You can plot all those points, and then you have your axis of symmetry, and then just make sure that your parabola open up or open down depending on your A, and then then you have everything you need to graph your function f. Is there any question, guys, about the graph of this function f here? Yeah, long steps to do, I know, but because I gave all the details, that's why it's it seems like it's very long, but it's not. I mean, if well, because I gave all the details about the computation, so it looks like very long, but I think it's not. I mean, anyway, yeah, I don't know. Is there any other question, guys? So I guess, oh yeah, when are we getting the review sheet? Yeah, tomorrow morning. Yeah, tomorrow morning. Yeah, so I guess, guys, I'm gonna stop here. We don't have time really to to practice those steps, but I will probably on Monday. So this section is included in the test. I would probably do 1 or 2 examples graphing parabolas on Monday. All right, so so the review sheet is going to be available tomorrow. So prepare your questions, guys. Try to solve the problems in the review sheet, and of course I will answer any of your questions on Monday. Right? Is there any question, guys, about the test, the review?
Yeah, Professor.
Yes.
So when
Yes.
is this gonna be?
The test?
Yeah.
The next Wednesday.
Oh, next week Wednesday. Oh, okay.
Yeah, next Wednesday this test, and Monday we're gonna have a review. The review sheet is gonna be available tomorrow on Blackboard, right? And everything is included in the test. Okay, chapter 1 plus this section. Yeah, homework for this chapter. Well, actually, you're gonna have like 1 or 2 problems about graphing parabolas in the review sheet. Okay, and but of course later, I guess, yes, I guess we're gonna have homework about this section. But we are done actually with this. We finished this section 2.2. Yeah, but we're gonna have problems in the review sheet about this graphing parabolas. Right? Is there any other question, guys?
I have a question.
Yes, please.
So everything on the review sheet is going to be on the test?
Oh yeah, everything. Yeah, of course. Well, actually, I mean, the whole chapter 1 and this section 2.2 is going to be in the test. And of course, all the problems in the homeworks, and the review sheet, they're gonna be in the test. So, of course, it's not. I mean, the test is supposed to be 2 hours and 15 minutes, right? So I think you're gonna have like about 10 problems.
Okay.
Mm-hmm.
Thank you.
There we go. Any other question, guys? Yes, I mean, homework number 5 is, yeah, homework number 5 is actually due today, but I think we have until 6 p.m. or 8 p.m. So yeah, you still have time, Frida, to fix mistakes in your homework. Yeah, sure. You can resubmit your homework. Yeah, no problem. You still have time. Yeah, sure.
Professor.
Yes.
Okay, can you clear my folder so I can resubmit it?
Which one?
The homework 5.
5, I don't know. I didn't check yet. For homework for number 5, I don't know.
I submitted it, but I want to resubmit it.
When did you submit your homework? Yesterday?
Yeah, yesterday.
Okay, I didn't check yet. The homework number 5, I didn't check it yet. So, yeah, I mean, if you have the mistakes in the homework, you can still fix. You have still time to fix your mistakes.
Okay.
Yeah, sure,
So
no problem.
I can submit. I can send it to your email.
Yeah, just send me to my email. Yes. Yes.
Did you take attendance?
Oh yeah, I did.
Okay.
So Abdullah, yes. What's your name? Yes, I took attendance. Okay, I see Abdullah here. All right. Anyone else? All right, guys. Well, so then if there's no more questions, I guess I'm gonna stop here, and I will see you on Monday for the review. Okay.
Thank you, Professor. See you on Monday.
Thank you. Thank you, guys. Thank you. Thank you, everyone. See you next time. See you on Monday.